Namaste. I, Jv'n Neha Sharma, JVWU University, Department of Science and Technology, Faculty of Education and Methodology. So our today's topic is framing of data link layer. So in the physical layer, data transmission involves synchronized transmission of bit from the source to destination. So data link layer basically doing what? Pack these bits into frame, right? So data link layer take the packets from the network layer and encapsulate them into frames. If the frame size becomes too large, then the packet may be divided into small size frames. And smaller size frame make flow control and access error control more efficient. Then it sends each frame bit by bit on the hardware at the receiver end. Data link layer pick up signals from hardware and assemble it into frames. Okay, so basically, if packet size is too large, then segment the frames in small size frames, and then at the receiver side reassemble again and get your output, right? So, okay, so here you can see in the diagram, here you can see sending machine and the receiver machine and the packet which coming from the network layer which is above layer of the data link layer in QSI model. And here you can see the frames. So header, payload field and the trailer, right? So part of frames, as we all well know, like frame header, it contains the source and the destination address of the frame. Payload field, it contains the message to be delivered. Trailer, it contains the error detection and error correction bit, so that we also control the error in data or in frames. So it contains the error detection and error correction bit and the flag at the end of the packet. You can see flag, so it marks the beginning and end of the frame. So if any frame is lost in between, so you can identify that a frame is lost in between, so you have to retransmit that frame, right? So this identified by this flag. Okay, so there are two type of frames basically in data link layer. Fixed size framing, second is variable size framing. So in fixed size framing and variable size framing, what is the difference? Basically, it is deal with the size of frame. Okay, so size of frame is fixed, the frame length act as a delimiter of the frame. Consequently, it doesn't require additional boundary bits to identify the start and the end of the frame, like ATM size. It is fixed, right? The size of the ATM is fixed, the data imported in the ATM is fixed, right? So there is a fixed amount of data and fixed frame is working there. So there is no need to require additional boundary bits to identify the start and the end of the frame. In variable size framing, the size of each frame to transmit it by may be different. Okay, so the size of frames are not fixed and they may be varying. Different size of frames are there. So additional mechanisms are kept to mark the end of one frame and the beginning of the next frame. So it is used in LAN, local area network. So two ways to define the frame delimiters in variable size framing are length field. Length field is also used in Ethernet IEEE 802.3. So length field is used that determine the size of the frame if it is varying by the size. Okay, and delimiter is here. Pattern is used as a delimiter to determine the size of the frame. It is used in token rings. If the pattern occur in the message, then two approaches are used to avoid the situation. If any pattern find, right? So first is byte stuffing and second is bit stuffing. So byte stuffing is what? A byte is stuffed in the message to differentiate it from the delimiter. So that you can identify, okay, this is not the delimiter, this is kind of some message stuff to differentiate it with the other frames, right? So this is also called a character oriented frame because a byte is stuffed to the message to differentiate it from the delimiter, like head and tail, right? So this is called byte stuffing, and the bit stuffing is a pattern of bit of arbitrary length is stuffed in the message. So here a pattern of bit of the arbitrary length means of any kind of length. stuffed in the message to differentiate it from the delimiter. So this is called bit-oriented framing. So in byte-oriented, you just import some byte, right, into the message to differentiate it from the delimiter, so that receiver identified that this is not the head and tail bit. This is something that is to determine the the pattern occurs in the message, right? So to defer that pattern, a byte is stuffed in the message, and in bit stuffing, a pattern of bit of arbitrary length is stuffed in message to differentiate from the delimiter. So this is called the bit-oriented framing. So here you can see the what is frame exactly in the data link layer, how data is transmitted from sender to receiver in data link layer, and what are the parts of frame, what are the types of framing, fixed size and variable size, then about byte stuffing and bit stuffing. So yeah, that's all for this class. Thank you so much.